Okay, a couple announcements before we get into the material. So the clickers, some people have commented that the clickers that they got for Chemistry 151 look slightly different. And I believe that they're actually the same thing. I tested one out over the last day or two. As long as on the back it says Turning Technologies, then the clicker is fine. Essentially, once everybody registers with online, and I showed how to do that last time, I'm going to provide a way for you to tell if your clicker is actually being registered. So let's give it another day or two. I'm going to try doing another clicker slide on the next one. Hopefully it'll all sort itself out. So the first homework is due 10 a.m. on Friday. Some people are having problems getting in to print the right dates. CJ's birthday in particular is causing some consternation. In particular, if you wanted to enter January of 2007, the way this formula works is you actually have to enter month 13 and year 2006. There are ways to get around that. It involves something we're going to see in Chapter 3. So because we haven't seen it yet, I obviously can't expect you to do it, your homework on it. February is entered as month 14 of the previous year. March is entered as month 3 of the current year. So most of the time, the problems that people have run into have generally been something along those lines. But if you are still running into problems, feel free to swing by any office hours, and we can certainly chat about that. There will be a homework out this Friday. That's going to be doing using objects. So we're talking now about objects and what to do with them. On Friday is going to be homework 2. Essentially, every week from here until the end of the semester, there will either be a homework and a lab or an exam and a quiz. Not counting spring break. I'm obviously not going to assign you a homework for spring break. As I mentioned last time, Lab 1 grades will be returned shortly, running into a minor problem with the program that I have to solve before I can actually return them. So we are working our way through Chapter 2, and we're moving towards the end of Chapter 2. I'm going to go a bit more into detail about some of the stuff that the textbook goes into. My guess is that we'll probably finish most, if not all, of Chapter 2 this week, and next week we're going to be starting on Chapter 3. So some people have wondered where we were in the textbook. The other thing is that we are going to be doing a course project. I mentioned this on and off. Essentially, the last 3 or 4 homeworks and the last 3 or 4 labs are all going to be components of a big course project. And when all is said and done, all of your the last 3 or 4 assignments, last 3 or 4 homeworks, the last 3 or 4 labs, will all magically work together, and you'll have some really big, cool program. We have a couple ideas for this. What we're going to do is I'm going to present them to you next week. Basically, a number of ideas that we could do for the course project. Then everyone's going to vote on them, not tomorrow, but next week in labs. And then realize that this vote is non-binding, so that I will certainly take what your thoughts into consideration. But if it turns out that the one that everybody likes is just not feasible, obviously I'm not going to go ahead and do that. So we have a couple ideas. Oregon Trail is one possibility. Hunt the Wumpus is another possibility, and a couple others I'm going to talk about all next week. Connect 4, although that doesn't seem all that interesting to me at least. So we're going to spend some time talking about that next week, and then everyone gets to vote in lab as to what their favorite one is, and we'll take that into consideration when we're figuring out what the project is. Other thoughts, ideas, questions, concerns? Okay. So we're working, oh, wait. There we go. Okay, so let's see how this clicker thing works today, and yet the board is, again, too low. And don't everyone answer 6. So is that saying that 5 people have registered or 95 people? 95. Oh, 95, right. Responses. Well, last semester we used a different clicker system, and it actually would stop at 5 or 10 people. Okay. Has everyone voted? No, it was 5 people. Oh, that's nice. Well, of the 5 people who voted, well, that's not much of a sample. Let's try this again. Okay. All right, try it again. Aim it that way. I mean, aim it at this little doohickey that's sticking out of my tablet. 0. So aren't you glad you bought these really nice, expensive clickers that work so well?
Actually, it's just an LED attached to it.
Yeah, pretty much. So everybody's aiming it, and yes, question.
It says on the box that we have to set a channel before it works.
Oh, really?
Oh, yeah.
How do you think I find out the channel? Okay. So when I tried this, all right, so I'm going to spend some time. As you see, I'm stumbling a bit on the clickers. So I sat there and I tried in my office, and I set up my laptop, and I had 2 clickers because that's probably enough for me to get for myself. And it just magically worked all by myself. And then, of course, I come into this lecture hall, and I can't obviously simulate 200 people all looking at me, wondering why my thing isn't working. So I will investigate the whole channel issue, and next time we'll ask how fast the lecture pace is. Whew, that was kind of embarrassing. All right, moving on with something that I know more or less works. We started talking last time about objects, how to create objects, how to call methods out of objects. And we're going to, essentially the rest of this slide set is focusing on what an object is, what a class is, and how you go about using them. And as we're going to see, every homework other than homework 1, which is due on Friday, is going to be based on using objects in some way, or creating objects, or writing classes, or all that other stuff that we're going to be doing. So, as a quick review, to rehash from last time, you can create a variable of a primitive type. Remember that a primitive type is int, double, character, Boolean. There are 4 other ones that we're not going to use as much: long, short, byte, and float. And pretty much those 4 types are the ones that we're going to use most often. You create a variable, int x, for example. You can assign a value to it. You can read a value from it. And that's pretty much all you can do. You can give it a value. You can read it a value. If used in a print statement, then essentially what is happening, system.out.println x, what is happening is that value is being read from the variable x and used to print out. So that's pretty much all you can do with the variable. You can read it or you can write it. So let's look at objects as a comparison. We've seen only 2 or 3 types of objects so far. We've seen the scanner class, although we haven't talked about it in much detail. We've seen the string class, and we've seen the rectangle class. It has many parts. The rectangle, remember, it has a height, a width, it has a line thickness, it has a position, a color, shading. I mean, very many different properties, as opposed to a type that can only have one property. Some people think of it as a complex type. I don't mind using that term now to sort of explain it. I don't want to start using that term in this class beyond sort of this week. We talked about methods. There's a substring method. There is the length method. Actually, we're going to be talking about those a bit more. Essentially, all objects have some sort of methods that do something. The rectangle object has a grow method, which will make it bigger, or an isEmpty method. It's not so important that you know exactly what isEmpty does or what grow does. Just realize that in the rectangle class, there are methods that do things. So let's talk about some methods in the string class. One of the methods is length. Not surprisingly, as by its name, it returns the length of the string. So if I was to say string s equals, quote, hello world, close quote, semicolon. Notice what I'm doing here is I'm creating a new string object. But also notice that it doesn't look the other string object creation lines we've seen. What happens is, okay, what color? So, all right, you got to use colors that I know here. So if I was to say string t equals goodbye, what happens is Java allows a shorthand for this. And if you can read my chicken scratches, this is why I have it written on slides as opposed to writing out by hand. I say string t equals quote goodbye close quote. That, as far as we're concerned right now, is the same thing as saying string t equals new string goodbye. What happens is that there's a couple types of objects that Java treats very differently. String is one of those. And in particular, if you were to say just this, quote, goodbye, close quote, Java will automatically fill that in for you. Those things are almost the same thing. We're going to see a difference for them a bit later. But the thing to keep in mind is that even though this just says string t equals something, it's still creating a new object. Java just sort of hides that. The reason is that strings are used a lot, a tremendous amount in Java. And people, as they were programming Java, were going to get kind of lazy, and they didn't want to have to write out new string every time. So they just write out equals, quote, goodbye, close quote. So keep in mind that even though this is somewhat of a shorthand notation, it's still, even though it's a shorthand notation, we're still creating a new string object. Then we can go and print out s.length. That's saying from the object s, which is the hello world object, I'm going to call the length method. What the length method does is it shows up how many characters are there. That's going to give you 11. And it's going to give you that value. So this is going to print out 11. This t.length is going to do the same thing, but for the t object. So that's goodbye. So that's going to count up the number of characters and give you that value. So that's going to print out 7. What's important to keep in mind here is that both times you call the length method, it does the same thing. It counts how many characters, and it prints that out to the screen. Or in this case, it gives that to the print statement to print out to the screen. So that's what the length method does. But the difference between those two lines is which object is called out of. S.length says from the S object, for hello world, I'm going to go and find the length 11. And t.length says from the T object, I'm going to go, or the goodbye object, I'm going to count the characters and print that out to the screen. So the method operates the same way, but it's operating on different objects. S.length versus T.length. So that gives us 11 and 7, which is printed out to the screen. All right. Calling S.length and T.length, both of them do the same thing in that they return the length of their strings, but since they're talking about different strings, the S string versus the T string, we're going to get different values. So let's look at this line of code. String wedding date equals August 21st, 1976. String month equals wedding date dot substring 0, 6. So that's saying from the wedding date object that was created in the previous line, here wedding date is a string object that happens to have that text in it. I'm going to call this substring method. What the substring method does is it returns part of the string. In particular, what it's going to return is that part. Starting at 0 and going until 6. And why it starts at 0 and what 6 means I'm going to talk about in a minute or two. But essentially that's saying I'm going to get the first 5 or 6 characters out of this particular string object. I guess the first 6 characters out of this string object. So now we have a second string, month. And month is the string that just has the word August in it. And then when we print it out here, we're just going to print out month is August. So what we've done there is we've called a method that exists in the string class, or in the string object, which basically gives us part of the original string. In this case, it's been set up so that it only gives us the first 6 characters. So you'll notice that it starts at 0 and ends at 6. Oops. Let's try that again. The way it works in Java is when you are talking about a string, the first character in a string is considered character 0. You and I would call it the first character in the string in English, but as far as Java is concerned, it's character index 0. The second one is 1, 2, 3, 4, 5. The space is 6. So even though you and I might say the first is character and there is A, Java looks at that and calls it the 0th character. Why it starts from 0, we're going to see in a bit, but it does.
Put your month to January, 7 characters.
January. Yes, well, January still has 7 characters. Well, so I'm not sure what you're asking.
So if we were using that, and like if we were putting available month, like different months out of 12.
Right, yes, and I'll get to that actually in a second. So the thing to keep in mind is all strings start at 0. And what this is saying is that when I say 0, 6, it's going to start at character 0 and go up to, but not including, character 6. That's just how the substring operates. That's just how that method works. It starts at the index of the first character, or the first index, and goes up to, but does not include, the second index. So the question was asked, what if you got married on January 21st, 2007, whatever year that is, January 21st of some year? This particular method just gives us the first 6 characters of the string. At which point, if your wedding date was January 21st, 1976, it would give you January, and just the first 6 characters of January, so you wouldn't get the Y. We're going to see how to extract the first month regardless of the length. But this particular code will just give you the first characters out of the string. It so happens that the first 6 characters corresponds to the month name. How many people feel comfortable with this segment of code? Okay, good. So prints out month is August. String fruit equals banana. And then search string equals AN.
I have a question about the last one. If say you wanted to extract just like the 21 out of that, could you say like int x equals, and then extract that and put that 21 into an integer instead of a new string?
The question was, is there a way to extract the 21 as an integer as opposed to a string? Yes, there is. We're going to see part of a way to do that in a little bit later today. And then, well, we're going to see a way to extract just a 21 as a string later today. There is a way to convert it to an integer. It's not quite as straightforward as one would think. So we're actually going to see that a bit later in the semester. Other questions about this slide?
When it brings out the month is August.
Uh-huh.
Period.
Yep. Because month is equal to just August, A-U-G-U-S-T. Because, so wedding date is the entire thing, but this wedding date dot substring 0, 6, that just takes out the A-U-G-U-S-T part, and that's what month is. Month is a string that has a total of 6 characters.
Why would you want to do that though?
So, okay, why would you want to do this particular thing, or why would you want to do this in general? So I'll show you examples. This particular slide, is it really necessary to extract out the first 6 characters of somebody else's wedding date? We're going to see a couple examples why you would want to use substrings in a minute. This slide is really just meant to show you how it works. Yes?
So if you're trying, on the print line, if you're trying to get something that isn't already put in data, you have to put the month in there. Like, the month is the period, you put the
I'm not sure what you're asking.
So when you do the system out print line, in order to get like month into the period, you have to put
In quotes? Yes. This is just saying that the print statement is saying color. The print statement is saying, I'm going to print out 3 things here. The first is that string that you've separated by quotes. The second is whatever month holds. Month happens to hold August. And the third is the period. So that's just saying I'm going to print out 3 things, and the plus is what tells Java I'm going to print out things 1, 2, and 3. Okay. Take a look at this code. Here we're creating 2 strings. One is banana, and the other is AN. The next method I want to talk about is the index of method. The index of method will search one string looking for another string. So what this is saying is I'm going to look in the fruit string, which is banana, and I'm going to search it looking for search string, which is AN. So it's going to search one string, banana, for another string, AN. I'm going to ignore the 0 for a second. So what this does is it goes through banana and tries to find the first occurrence of AN. And it so happens that the first occurrence of AN is here. Well, remember that whenever we, so what this method returns is where in the string it's found. And it so happens that strings start from 0. 0, 1, 2, 3, 4, 5. So that's the index number of each character in that string. So AN is first found starting at character 1. Right, that's where the first AN is found, at character 1. So that's going to allow us to create a new int variable, n1, that has value 1. Yes?
Is of capitalized or
Yes. The question is of capitalized. This is a, whenever you have a method that is many words combined into one, the first letter of each successive word is always capitalized. So it's indexed in capital O, F. So you'll notice that there's one other thing in that particular method call, which is this 0 here. That's telling you where to start. Right, we'll get back to that in a second. That's telling you where to start. So that's saying starting at character 0, or B, I'm going to search for AN. So it's basically saying start at the beginning of a string and look for wherever AN is found. So then we're going to look at the next line. Int n2 equals fruit dot index of, or inside the fruit string or banana, find the first occurrence of, again, AN, or search string. And here it's saying start at n1 plus 1. Well, we know n1 is 1, so n1 plus 1 is 2. So that's saying start at, get rid of that, come on. That's going to start at character 2, which is the third character in the string. And we're going to search for AN. So it starts at that spot and moves to the right. And it so happens that the next occurrence of AN is at character 3. So this method call is going to return the character 3. How many people fully understand why N2 has 3 in it? Okay, I'm seeing some hands. You'll notice that this method takes in 2 parameters. The first is whatever string we want to search for. In this case, it's search string, which we've defined above to be AN. The second parameter is where to start. We can't start all the way at the left or the beginning of the string, or we can start partway through. The first time we call the method, the N1 line, we're saying start at the very beginning of the string, or character 0. Character 0 is the B. So it's going to start at character 0 and keep moving to the, I guess that's the way it is, you're right. Keep moving to the right until it finds AN, and it finds AN at character index 1. So that's why N1 has value 1. The next line says I'm going to start one position after that, or I'm going to start at N1 plus 1 or 2. Well, character 2 is the first N. So it's going to start partway into the string, keep searching to the right until it finds AN. And it so happens that AN is at character 3. So then N2 is going to have 3, because that's the second occurrence of AN in banana. Yes?
So if you wanted to find another A, but you wanted to start later, would you put N1 plus 2 or plus 3? If you wanted to start later on in the sentence?
You could. I mean, so the question was if you wanted to find the next occurrence of AN in the
Like
string.
you have a big sentence and you only want to take one small word out in one place and then you want to go all the way to the end.
Yes, then you could just add 4 or 5 and search after that.
Instead, we could do like plus plus in one.
Well, the question was, can you do plus plus N1? You could do plus plus N1, but that would also modify the value there and make that 2. So then the last line says, I'm going to take N2. So N2 we know is 3. I'm going to add 1 to it, and we're going to get 4. So I'm going to start at character 4, which is that one, and start moving to the right until I find another AN. So it's starting at the second to last character, or the last N, and it's going to keep searching to the right until it finds another AN. And as you know, as you can see, there is no AN at that point in the string. So the substring method could do a number of things at this point. It could just say it's not found. It could wrap around and start at the beginning. It could just crash. The way the substring method is defined, if it doesn't find the string that you are searching for, or that you told it to search for, it's going to return value -1. Remember, the value that it returns is where in the string that search string is found. So it's always going to be a non-negative value if it's found, right? Because 0 is the beginning, and then 1, 2, 3, 4, 5, all the way to the end of the string. If the value is not found, it's going to give you -1. If I was to say fruit.index of x, x is not in the string banana, it's going to give you -1. Or in this case, when I'm giving you N2 plus 1, or saying start at character 4, there is no AN found after that in the string, so it's also going to give you -1. So then it's going to go through and print all those out, and those are the values that it returns. Look, I got it right. How many people feel comfortable with this slide? Okay, I'm seeing a good number of hands. All right. So, every December, well, sort of towards the end of every year, they give out the Nobel Prizes, which are obviously widely considered to be the top awards in their respective fields. And the Nobel Peace Prize is widely considered to be the best of those. And, you know, they give it out to people who have done great things. And it turns out that there's also a somewhat lesser-known series of awards called the Ig Nobel Prizes. And these are given out, I forget if it's Harvard or MIT, because I know it's in Cambridge. And these are given out every year just before the Nobel Prizes for slightly less well-done research. And you have a whole series of fields, just like the Nobel Prizes, but the fields are somewhat arbitrary, and they kind of make up ones. So here we have medicine, physics, public health, et cetera, et cetera. And these are the Ig Nobel Prizes given out in 2004. So for medicine, somebody did an article that studied the effects of country music on suicide. Because country music is depressing, and it's always sad. And it turns out that there was an increased correlation, not causation, but correlation between people listening to country music and suicide rates. Physics, somebody sat there and explained the dynamics of hula hooping. Public health, you know the 5-second rule where you drop something and quickly pick it up? Well, they studied it, and they found that there's not enough bacteria that will get on something within 5 seconds that could seriously harm a human. Now realize that this is, like many research, maybe it's true or maybe it's not, so don't keep dropping things on the floor, pick it up, get sick, and blame me. So the Coca-Cola Company of Great Britain got the award for chemistry. Coca-Cola's water is Dasani water. And they ran into a couple of problems in Britain. It turns out that they were taking the water out of the River Thames. The River Thames, for those who don't know, is about as clean as the East River going past Manhattan. I mean, it's like horrendously polluted. Like if you fall in, you go to the hospital for amoebic dysentery care. And then it turns out, so that first got released and no one was buying Dasani. And then it turns out that they weren't purifying it very well. So less people bought Dasani. And then they were adding something to make it taste good. Since they weren't purifying it, they wanted to make it taste good. They're actually adding a carcinogen into it. So it's now cancerous, pure spring water from the River Thames. At which point, the British equivalent of the FDA yanked it from the shelves. Engineering, for the patent of the comb-over, somebody actually applied for and got a patent for it. That's, where if you're a ball on the front, you take what little hair you have and you... Literature, the American Nudist Research Library for preserving American nudist research for years to come. So psychology, they did this one study where everyone's focusing really hard on what the instructor's teaching about substrings and whatnot. And somebody came in a gorilla suit, sort of hops across the stage like this, and it turns out that people didn't even pay any attention because they're so focused on the substring lecture. Wherever it was. Economics. So I'm not Roman Catholic, so you'll have to help me here. But apparently in Roman Catholicism, you can pay somebody, or you make a donation, somebody else will pray on your behalf. And it turned out that the Vatican was outsourcing those prayers to India. Peace, for the invention of karaoke, thereby providing an entirely new way for people to learn to tolerate each other. And biology. We're showing that parents apparently communicate by farting. So every year, they give out these prizes that first make people laugh and then make people think. And they actually bring real Nobel laureates to actually give these prizes. And sometimes when people show up, I don't think Coca-Cola, for example, showed up to get their prize. But I can totally imagine that some of these other people did. And it's pretty entertaining. So over the course of the semester, I'll explain a couple other Ig Nobel prizes that were awarded. Okay. So the question was asked, why do we care about substrings? And it's a perfectly valid question. I'm going to show you some programming examples that use substrings. And as the semester goes on, you're going to see how we build upon the basic string methods in an effort to create bigger and better programs. So consider this particular, program. A lot of it is stuff we've seen. Public class word length, public static void matrix, bracket arg. So here we create our scanner, and we tell the user to enter a word. Notice here that we are calling the next method. Not next int, not next line, just next. If it doesn't have anything after it, next int, next double, if it's just next, that reads in a string from the keyboard. There's also something next line. I'm going to kind of ignore the confusion between them. But essentially, that's reading in a string. So now word is going to be whatever string happens to have been typed in by the user. Word blank. Oh, I want a different color. There we go. From the word object from the previous line, I'm going to call the length method, which will then figure out how long it is, count the number of characters, and that's going to be stored in the int variable word length. And then we print it out. So in case you didn't believe me, I'll run this for you. Ready? There we go. Oh, by the way, some people have commented that their JCreator doesn't pop up a black box, but instead shows it here. That's fine. This is a slightly different version of JCreator, but it's all the same. So I type in my word, and it tells me that I just typed in, it says word blah, 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 has length 31. Ooh. Okay. So that's an example of how we might use the length method. There's one or two other methods I want to introduce, and then I'm going to get to a somewhat more useful program. Trim. Trim will take a string, any string that you type in, and remove white space from either end. So white space is, if you print something out on a white piece of paper, anything that is not a character that prints is white space. In particular, a tab, a blank line, a space, that's all considered white space, any tab character or return. So it's going to take it off specifically off of each end. So if I have a string like that, a couple spaces, foo, and a couple spaces, actually, no, let's do this. And I have a couple spaces here, a space there, and a couple spaces there. Trim will just take off any white space from each end. So that string will become that, those 7 characters. White space in the middle, such as the space in the middle of that string, is left intact. It's just white space on either end. Right. It's a space, a tab, or a return. So, now armed with such methods as index of, length, substring, and trim, what we're going to do is we're going to write a program that's going to take a date in American format, July 12th, 1776, or whatever date it is. I guess it's not really July 12th, though. And it's going to return it in international format, which is a more international standard of doing it, the day, the month, the year. So this is an outline of how our program is going to work. You'll notice we have the 10 or so steps that our program is going to do. In particular, produce a legend. This is a date translator. Prompt the user for a date in American format. Please enter a date. Acquire the input entered by the user. We're going to have to create a scanner, and we're going to have to read in a date through the .next method. Step 4 is echo the input back. That just means print out the date you entered is such and such. Get the month, day, and the year entered by the user. And this is when we're actually going to start using the string methods. Create the standard format of the date, meaning rearrange everything, and then print it out. So these are the different steps that it's going to do. And there we go. And that's a program. Granted, it's, we include Java that you pulled out stars so that we can use the scanner. It's in a class called date translation, and we have the main method. Okay. So printing the legend, we talked about this for the homework. It's just something that tells whoever's writing it what the program does. Rather than enter input, which is kind of vague as to what it's looking for, it will just say, please enter a date in American format, July 4th, 1776, and then we'll print it out in a more international format. Prompt the user to enter the date. It's just a print statement. Please enter the date. Acquire the input. That's going to create a scanner object, stand it in. And I think we need to work for this. Read in the date into a string called buffer1. So now buffer1, which I'm just going to write up as buff1. That's what buff1 is. It's a string that was just entered by the user. You'll notice it uses next line instead of next. There is a difference between them. I want to ignore it now because it's really just kind of annoying. Echo the input back. That's pretty easy. We're just going to say the translation of buffer, or the translation of your date, and it's just going to print out the particular date that was entered. So the real heart of this program, and why we are going through this exercise, is we want to extract the month, the date, and the year. So string buffer2 equals buffer1.trim. What that's going to do is remove any extra spaces that was before or after the string. So if I enter July 4th, 1776 on a couple extra things, buffer2 is just going to be July 4th, 1776. So it just removes any extra spaces before and after. Int m equals buffer2 dot index of space. Remember what index of does is it searches for the given string, searches for space in buffer2. So this is going to search through buffer2 until it finds a space. Well, the fifth character happens to be a space because we entered the month of July. If we entered January, it would be the 8th character, right? If we entered August, it would be the 7th character. So that's going to search through it. Remember that the fifth character actually has index 4, right? Because it's 0, 1, 2, 3, 4. So what's it called, M? M is going to be given value 4. Because it's the fifth character or character index 4 in the string that has the space. String month equals buffer2.substring 0, m. So I'm going to look at buffer2, and I'm going to call substring of 0, m. We know m is 4, so 0, m is 0, 4. It's going to take the first 4 characters out of that string. Month equals July. Now, if this was April or September, it would still take out the entire month because we found where the space is and we're taking out everything up to but not including that space. So then we say buffer3 equals, it's the bottom lines of that stanza, buffer2.substring m plus 1. You'll notice that here in substring, we've only provided it with one value, m plus 1. Well, m is 4, m plus 1 is 5. That's going to start at character 5, which is 0, 1, 2, 3, 4. It's going to start at character 5 and basically do everything until the end of the string. So buffer3 is going to be 4, 1776. What this is saying is that substring works differently. If you provide 2 parameters, such as 0, 4, one line above it, it starts at 0 and it ends at 4. If you just provide it with one parameter, such as the line that's highlighted, it's going to take everything from that point to the end of the string. So from buffer2, it takes everything from 4, because this character 4 happens to be character index 5, until the very end of the string. So now buffer3 is 4, 1776. At that point, we've now extracted our month. String buffer4 equals buffer3.trim. What that's going to do is just take out any extra spaces on either end. There aren't any in this case, so it doesn't do anything. So buffer4, because there aren't any extra spaces, it's still 4, 1776. This searches for the first index of the comma in buffer4. The reason is we don't know how long the day is. It could be 2 days, 4 weeks. That's the search for the comma.
And of course it returns double.
It then is going to call trim on the year, and that's going to be a new string year. So through this, these various method calls, lines, 30 to 43, it was able to extract from any date the month, the day, and the year. We then put them together in a slightly different format. Notice the plus is a way to put strings together. So we take the year, we add a dash, the month, another dash, and a day, and we print that out. So if I was to run this, I can type in backwards. I use a slightly different year, but I did July 4th, 8765. It goes and it properly extracts the day, the month, the year, and prints it out. How many people feel they understand how this program works? Okay, I'm seeing a good number of hands. So, I know that I went through this in a fairly large amount of detail. The reason is I want to make sure that how these things work makes sense at this point, because once we understand how the basic things, methods and whatnot works, we're going to be moving on into a lot more complicated stuff. So, wait, I still have a couple minutes. In fact, I have like 3 minutes. Mediocrity. It takes a lot less time, and people won't notice the difference until it's too late. So you notice that the ground is tilted in this, so they basically went there and they tilted the camera so that the tower doesn't lean quite that much. My stepfather's a civil engineer, and I actually got this for him. He didn't like it too much. Mistakes. It could be the purpose of your life is only to serve as a warning to others. Trouble. Luck can't last a lifetime unless you die young. Stupidity. Quitters never win, winners never quit. But those who never win and never quit are idiots. All right, I'll stop there and I'll see you on Friday.